core components of an AI agent. Very important because this is where you move away from prompts to an agent now. As you saw yesterday in the session, the LLMs can have several types of prompting, like React. React stands for reason and act, chain of thought, or tree of thoughts for that matter. And when you take such prompt, and you can have any of this neatly defined prompt, and now augment that with RAG, which is from a retrieval database retrieval perspective. Augment that with tools where it can call certain tools to do certain work, and also give it memory because, as you know, I mean, LLMs do not have memory; they are stateless. So, but to an agent, you can provide a memory. So this is when a so-called large language model function system prompt gets kind of evolved into an agent. And when it comes to deciding how to go about an agent, choosing the right LLM is very important. Sometimes you may not end up choosing the right LLM. So, hence, like I said in yesterday's call, always start with the cheapest model like GPT-4o mini, so that now you can see where the model breaks. If it is high reasoning, then move on to the next levels of reasoning. And then instead of doing the other way around, because if you start with GPT 4.1, the latest model, or Claude 4 or Claude 3.7, when you choose a very high power model for all your agents, you are automatically robbing the possibility of or eroding the possibility of having a highly, I would say, cost optimized way of running these things. There is a recent study. I'm not able to find the paper, but I'll share it if I can find it a little later. There was an experiment that was conducted by, I think, MIT researchers or Stanford, one of these two, where they found that they kind of simulated a real-time environment with agents. And because agents kind of go into its own self-learning loop over and over again, they tried all of that eventually to figure out that the cost advantage of humans to agents kind of started diminishing as the agents went into a loop uh, to try and solve a problem. So, long story short, it is always it's always useful to start with smaller agents and then smaller LLMs, rather the cheaper LLMs, before you kind of upgrade. I would suggest that instead of the other way around. And number two, choose the right LLM for the right purpose. If you are using web search, go with Perplexity or Exa, two really good models. If you are looking at reasoning, go with Claude 3.7 or Gemini Flash 2.5 or GPT. O3 is okay, but O3 is still okay. I can still go with O3. That's the latest reasoning model that they have, or any of these open source ones like Quen and DeepSeek. And number three, start building a prototype and focus more on accuracy, focus more on which agent an LLM combination is able to follow the instructions a lot closer because you need the output consistency to happen. And number four, uh, you start now playing around for cost and latency because you can swap the LLMs for each of these agents that you build. Anything around conversational in nature, you need low latency. Anything around, say, planning and execution, you need better reasoning. So you can swap them. And number five, the context window, right? Don't try and push a lot of things. I think I answered this in one of in yesterday's session. You try and kind of build a mega prompt and see if the agent is able to consistently follow the instructions. But if it fails, now break it down into two agents and run the whole test. If it fails, break it down to three or four agents. So you start breaking it down. And at schools, we would have seen those amoebiasis, right, where the amoeba starts breaking into multiple smaller amoebas. That's a very good way to think about it. Try and load everything in one, and then you start breaking it down into two, three, four agents, and then you will kind of get to the state you are. This is a very iterative process. I follow slightly a different approach, which I will speak about shortly. I do the other way around, which is take a business requirement and break it down into tasks. You can actually interview your customer. I mean, if you are within an organization, if you're an automation expert within the organization, go and your customer would be the actual business person or the domain owner. Speak to them and start asking them, tell me exactly step by step what happens, and then start breaking it down, which will allow you to now get a long list of tasks, granular tasks, and then now you can start combining them into agents. Let me show that with an example. So this is a customer onboarding agent that we built for a bank. Now, the customer onboarding agent starts with, so there are three steps here that happens. Step one is the agent collects the account opening form, which is an OCR agent, and it then converts the account opening form into raw text. And then from the raw text, it has to extract the actual data about the customer. So there are three processes involved: converting, or rather, first of all, receiving uh, the whole document, converting into raw text, and then extracting the information. So let us see how it works. So we have loaded the OCR process when we have loaded the document already in the backend. So this is how the multiple steps that are happening on top, as you could see: OCR processing followed by a human in loop approval, then Mareva injunction, which is nothing but anti-money laundering checks that happens in Singapore, and then another human approval, and then the account creation, and finally another human approval. So the PDF processing is happening here. As you see, it's a 6-page document with a lot of information about who the customer is and their details. And this is a free form OCR conversion. We actually launched the OCR agent. You can try it out here, OCR agent.studio.liza.ai. There is also an API endpoint to it. So that's what happens here. The OCR agent takes the document and converts that into raw text. This is step number 2. It converts into a raw text. And step number 3 is, from the raw text, you're able to extract the actual structured data, which is required for the next agent to process. So 3 steps are now converted, or rather combined, in one single agent, which is the OCR processing agent. And then the human loop comes into picture, whereas a human, they read it, they're okay with it, they're confirming it. And now it moves on to step number 2, which is the anti-money laundering checks. Again, like I said, in Singapore, it's called Mareva injunction. So it does checks against multiple databases, and it passes the company verification, the owner verification, the financial verification, and then approve and continue. A human in loop happens. Then you are moving to step 3. Now, step 2 alone, agent number 2, Mareva injunction, it is one agent, or rather one multi-agent system here, but it does 4 different steps because it has to check against 4 different databases. And then you're moving to the third set of agents, which is the account opening agent, where it asks what kind of account you want to open to the internal customer onboarding team, and because they know who the customer is. And now the agent goes ahead and creates the necessary documentation, including the account opening, I would say, the instructions, and a welcome email, and so on. So this is how you kind of first break down tasks and start combining these tasks into agents. Here it has written the general account instructions. It has also created a notification letter. So it actually saves a lot of time, and it goes through a final human approval, and then the process completes, and you can see the whole dashboard here. So this is a good example of how a customer onboarding process was first broken down into simpler examples, simpler tasks. And from simpler tasks, you start combining them into agents. And again, the same process repeats, right? You try and push all of this into a context and see whether you're able to repeat it without breaking the process. If not, then start breaking it down into multiple individual agents. So that is how the whole process evolves over a period of time.